Well, hello Internet and welcome to my Ultimate SQL tutorial. In this tutorial, you're going to learn everything you pretty much want to know about SQL using MySQL. This is basically a 500-page book all crammed into one video, and underneath the video, you're going to see table of contents that you can click on to jump throughout the video to learn exactly what you're looking for. I'm basically going to cover everything from installation on both Windows as well as Mac OS through stored procedures, functions, triggers, database design, and everything else. And I have a lot to do, so let's get into it. Alright, so the very first thing I'm going to do is cover how to install MySQL and MySQL Workbench and everything else you're going to need. So what you're going to want to do is go to dev.mysql.com/downloads/installer. And you're specifically going to want to come down here where you have MySQL Installer Community and click on Download. Whenever you do, you're going to be forced to log in. So you're either going to log in using your Oracle account or you're going to click on Sign Up. Everything's free, so do whatever you need to do. In this situation, I'm going to log in. So I'm going to type in my user ID and password, click on Sign In. Then it's going to allow me to download the Community Installer. I'm going to click on Download Now. Whenever I do, it's going to install here, and I'm going to be able to click on Open to start the installer. I have to give it permission to actually run, so I'm going to click on Yes. This message is going to pop up. I would just click on Yes. We are specifically going to use the developer default, so select that and click on Next. This is just going to pop up. Again, click on Next. And basically what we're going to be doing here is you're going to be downloading and then installing all these different requirements and all these different parts of the MySQL ecosystem. And as you do it, some of the downloads are going to fail. You're going to have requirement issues and all kinds of stuff. I'm going to walk you through that entire process. It's very easy to solve. All you basically just have to do is keep clicking retry, 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 and eventually everything installs. So come down here and click on Execute. And then you're going to get all the individual parts of the installation. I'm going to click on I agree with the licensing terms and click on Install. And then all the individual parts are going to download and install. And then whenever they do, just click on Close. Again, another part comes up here. We just need to accept the license and click on Install. And then the installation process will continue. And whenever the installation is finished, we're just going to click on Finish. And you can see all the different check marks as the different things are being installed. Click on Next. You're going to get a message like this where it says requirements have not been satisfied. Just click on Yes. And then you're going to see all the individual parts that we are going to download. Your list might be slightly different than mine because I don't have Microsoft Excel. You might have Microsoft Excel in here or something else. Don't worry about that. Just click on Execute. And then all the individual parts are going to be downloaded and installed. If there's a check mark inside of there, that means everything's good. Sometimes the installation or the download is going to fail. In that situation, you're going to see these exclamation marks. Don't worry about them. Just click on Try Again, and they will install, and they will work properly. And if you keep clicking on Try Again over and over and over again, eventually you're going to see Complete everywhere here. In that situation, you know that everything's been downloaded and installed. Click on Next. You're going to see a message like this. Just click on Next. I'm going to use the standalone MySQL server, so just put a mark inside of there and click on Next. Don't change anything here and click on Next. I decided to use the legacy authentication method just to ease the learning process. It's not going to change anything. It's just going to get some things out of your way whenever you're learning how to work with MySQL and SQL. So I would choose to use the legacy authentication method with a check mark there and click on Next. You're then going to have to define a root password. This is going to be like the master password for working with your databases. So type in a password inside of there and click on Next. I also chose to click Add User and enter in a new username. You don't have to do that, but I did. And then you're going to have to give that user a password as well and click on OK if you so choose to do so. Don't change anything here. Again, click on Next. Everything here is perfectly fine and just click on Execute. As you do, everything's going to be set up properly for you, and at that point you can click on Finish. This message is going to pop up, click on Next. Don't change anything here and click on Finish. This message is going to pop up. You're just basically going to be clicking on Next a couple times. You're going to have to type in your root password here. Whenever you do, you'll be able to click on Next. You can see here the connection was successful. That's good. Click on Next, and then just click on Execute. Everything's going to be completed, and you can click on Finish, and then just click on Next. And I chose to start the MySQL Workbench after the setup as well as the shell. Click on Finish. and this is the MySQL Workbench, which is what we're going to be using in this tutorial. And this is the shell. We're not going to use it, but you will be able to use the shell based off of what I'm going to teach you in MySQL Workbench. A lot of the stuff that works over here is going to work exactly the same over here. So you're just going to type in quit over on this guy, and then you're going to click on local instance MySQL 80 right here. You're going to have to enter in your root password and then click on OK. Whenever you do, MySQL Workbench is going to be ready and you will be ready to work with this tutorial. And here it is full screen, and we know that everything is properly working. So that is how we get everything working on Windows, and now I'm going to show you how to set up everything on Mac OS. Basically, the installation on Mac OS is going to be very similar. You're going to go to dev.mysql.com, downloads MySQL. You're going to select your operating system right here. The easiest way to install everything is to use the DMG archive that you see right here. So just click on download. No doubt whenever you do, if you're not currently logged into your Oracle account, it's going to either have you sign up for one or log in. It's free, so don't worry about it. In my situation, I'm going to log in, type in my user ID and password, click on sign in, and then it will allow you to download everything. So just click on download now. It's going to pop up down here. We're going to come down and click on open. Whenever you do, you're going to see this pop up. Just double click on it. This message is going to pop up. We're going to click on continue, and then we're going to click on continue, and then we're going to click on continue. You're going to have to agree to the terms, so click on agree, and then click on install. I chose to use the legacy password encryption because it's going to get a whole bunch of things out of your way as someone who's learning how SQL and MySQL works. So I would recommend you do the same. So click here and click on next. It's not going to keep you from learning anything. It's just, there's different things that are just going to get in your way as a beginner, or either an intermediate or either an advanced person working with SQL. So that's why I chose to do that. You're going to have to define a password for your root user, which is going to be the master of your database. So choose a good password and click on Start MySQL Server once the installation is complete, and then click on Finish. Everything is going to get set up. Then what you're going to want to do is come down here where it says System Preferences, double click on that. Whenever you do, you will see MySQL down here at the bottom. If you double click on that, you're going to see that the server is running, which is a great thing. So you can now come in here and close that. Then we're going to execute MySQL Workbench. So just click up here where the little magnifying glass is and type in MySQL Workbench and then double click on it. And here it is. And then we'll just come over here and double click on this. Enter in your root password, click on OK. And then MySQL Workbench opens up and everything's looking good. Alright, so now you have MySQL Workbench and MySQL and numerous other different things installed. Everything's ready for the tutorial, and so now I'm going to jump into the tutorial. Okay, so a small part of this tutorial is going to be slides. The vast majority of it is going to be me typing in code and executing it, but I just wanted to let you know right there. I'm just going to use some slides to help explain the overview of what we're going to be doing. Now, a database is just data that is structured into rows and columns like a spreadsheet. And to receive or change data in a database, you send commands called queries, and then the database in turn returns a result based on that request. Databases contain many tables of data that is organized into rows and columns, and each column represents one type of data the database stores. And then each row contains multiple pieces of data that are specific to each entity you are describing. So for example, we store information on customers here. Each individual value stored is called a cell, and primary keys are used to define unique entities in your tables. And you can also have non-unique keys, which are just referred to as non-primary keys. So for example, let's say we want to store possible countries in a table with an associated key for each country. We could then refer to those countries in our tables, but because they aren't unique for each customer, they can't be used as primary keys. In this situation, customer ID in the sales table is called a foreign key because it refers to a row of data in a separate table, being the customer table. Now, you're going to be able to have multiple foreign keys in a table, but only one primary key. And if any of this is confusing, don't worry about it. I'm going to be showing you so many examples using primary keys and foreign keys and all these other things that I'm mentioning that by the end you will completely understand them. Now, primary keys can be made up of multiple columns. In that case, they're called composite primary keys. But don't worry about that for now. I'll cover that later. And here it is possible to have multiple references to the customer table in the sales table. And you can see that customer 9 is actually listed twice. And in that situation, that is known as a one-to-many relationship. And I'll get more into that later as well. So now we're going to jump over into the MySQL workbench, and I'll show you how to create a database. Now, to create a database, all you need to do is click this icon up here, which looks like 3 cylinders stacked on top of each other. So just click on that. And that little guy right there is actually called Create New Schema. And MySQL just refers to databases as schemas. So that's all that is. So what you want to do here is go in and give a name for your database. I'm going to call this Sales DB. Leave everything else exactly the same. And you're going to come down here where it says apply and click on apply. Whenever you do, it's actually going to show you the query you would use for creating this new sales database. So just come down here and click on apply again. And then it says SQL script was successfully applied to the database. So click on close. And now you can see your sales database is right here. So now what we're going to do is create a customer table. And you can come in here and close this to get rid of it. And click on your sales database that you have over here. You can double click on it. It's going to show you tables, views, stored procedures, and functions. I'm going to explain to you what every single one of those things are, and we're going to work through examples on them. So just double click on the sales DB if you haven't already. And then we're going to click on the Query 1 tab right here. And you're going to come in and we're going to create a customer table. Now to create a table, we're just going to type in create table. And I said that it's going to be called customer. And then what you have to do is just to define all of the pieces of data inside of it and the type of data. So for a customer, you might want to know something like their first name. You're then going to define that this is a string of characters that are going to be 30 characters in length. And we're going to type in not null. That means that if somebody tries to enter data into our customer table, we must receive a first name as part of the data that is received. I'm also going to come in and say that I want the last name. So I'm just going to type in last name. Again, I'm going to say 30 characters in length. Then we're also going to ask them for their email. And you may note that the commands that are specific to MySQL are going to be in uppercase letters. And everything else is in lowercase letters. My email, I'm going to say that I want that to be 60 characters in length. Again, not null. Not null just means I must get that. Otherwise, I'm not going to allow you to put information in my table. Company, again, variable number of characters, not null. And we'll get into other data, different types of data, of course. Also going to say that I want to know the street, variable number of characters. Let's change that to 50. What else do we want to know about our customers? Well, we would also like to know the city in which they reside. And let's say that the number of characters there is 40. The state, I'm going to say that that is going to be 2 characters in length. I could also come in here and go characters and 2. Zip. Now there's going to be different types of ways to store numbers. I'm going to show you that in a second, the specifics of them, but I'm going to use a medium int here because that makes sense for the size of the zip code that I'm going to be expected. I'm going to say that I expect this data to be unsigned. That means I don't have a negative zip code. And again, I'm going to say that I require it. So not null. Null is not a available piece of data to put inside of here. I'm going to say that I expect a phone number. Let's just come in here and do this. Whoops, wrong thing. Down here, there we are. I'm going to say that I want my phone number. So I'm going to say phone, variable number of characters, and I'm going to say 20. Again, not null. I'm going to say that I want to get their birth date, and there is a date data type that I want to use in that situation. But let's say that it might be hard to get a customer's birth date, and for some reason or another. In that situation, I'm going to say that null is acceptable. Sex is going to be either male or female. So I'm going to use an enum, which is going to be a list of potential pieces of data. So we're saying that I expect male or female to be input inside of there. Again, I'm going to say that I demand to get that piece of information. Let's say that I also want to track when the customer was entered into our database. In that situation, I'm going to say that I want to use a timestamp data type, which is going to allow me to store both dates as well as times. And I'll say that I want that to be definitely put inside of there. And then you're going to see our ID. This is going to be our primary key. This is going to be a unique number that is going to be specific to each individual customer that I input into the database. It is going to be an integer. It is going to be unsigned, so it's not going to be negative. It is going to be not null. I can also go down to the next line without causing any type of an error. I'm also going to say that I want this to be auto-incremented, so the first time I enter a customer into the database, it's going to receive a value of 1, and the next number is going to be 2, and so forth and so on. That's what auto-increment means. And then finally, I'm going to say that it's a primary key. And that just means it's a unique key that is going to represent each customer. Then, after I go and finish defining what I want my table to look like, I just click on this lightning bolt up here. And then I can come over here on the right side. Well, first off, if you come down here, you're going to see there's no errors, so that's a good thing. Then I can come over here and right-click on this and say refresh all. And now you're going to see that I have customer table right here. And if I click on it, you're going to see all the specifics of how that customer table is set up. So I said I was going to talk about the different data types that are available. And these are the most common numeric data types. And you can see their minimum as well as their maximum values. And the float data type is purely theoretical, and its precision is going to be dependent on your specific machine. And actually, it's nothing even to worry about because the float data type has been deprecated, which means that it can be used, but it may be removed at some point in the future. And what has replaced them? Well, the decimal data type. And decimals are exact numeric data values. And whenever you are defining them, you use the form of decimal. And then 6 is going to represent the number of significant digits of the entire number, while this second value here is going to represent the number of decimal precision-wise. So if you typed in 62, you're going to see 1, 2, 3, 4, 5, 6. See, 6 digits and 2 precision points for the decimal. You're also going to see the format for date as well as date time, and you're going to see the maximum value for your date time data types that you input. This is what a timestamp is going to look like. You can see here it has the year. This is the maximum value you can store in a timestamp. All of these are the maximum values, and you also see that we have the hour, minute, seconds, and milliseconds that you can store. Time is going to take this format, and years are going to go from 1901 up to 2155. Like I explained when I was creating the customer table, you can define how many characters you wish to store in a variable character. And that's going to be as long as the maximum is 255, which is offhandedly the maximum size for storing an 8-bit number. A blob is going to be able to store up to 65,535 characters. And then you can also see how many characters are going to be able to be stored in the other different blobs. Enums are going to store distinct elements, such as male or female, like you saw previously, and that's how many of those you can work with. And sets are basically just like enums. Here's some other different data constraints. So you already saw not null. That just means that it must have a value. It can't have a value of null. Default, which you're going to see later, is going to designate a default value whenever a row is created without data. Unsigned means that you cannot use negative values. Primary keys are identified as unique values assigned to a row, and if you mark data as auto increment, each time a row of data is created, you would mark anything that is set for auto increment to null, and the database will automatically go in and increment that value. But it's important to know that you can only use auto increment on one column per table, and in that situation, that column must either be a primary or a unique key. Now, whenever you are designing a database, it's very important to understand that each table should represent one real-world object. Also, each column stores one piece of information about that object. You should define how tables may relate to each other using either primary or foreign keys or both. And you need to reduce redundant data, and this is called normalizing databases. One really great way to think about how to create a customer table and a database overall is to use a real-world way of marking down and tracking information in regards to orders. So I went and created a fake invoice, which is basically what invoices look like. And I'm going to take this company invoice and then translate it into a database. So very first thing that I'm going to want to do is whenever I want to create a customer table, I could have just went in here and created one field named address, but in doing so, it is much better when an element contains two or more pieces of information to split those up into separate elements. And you can see that's exactly what I did. On top of that, I added additional information that may be important in regards to dealing with a customer, such as their birth date and sex, as well as the date the customer was added to our database. I'm going to also create another table that is going to be extremely similar, which is going to be salesperson, and I can create that here in a second. And you can see all the individual pieces of information there. One thing that is different, however, is I got rid of the company because it's our salesperson, so we know that salesperson works for us. And also I changed date entered to date hired here, which makes more sense. So why don't I jump over and actually create this salesperson? All right, so this is just going to be salesperson. So I'm going to go salesperson, and largely this is going to be exactly the same. Remember I said company isn't going to be here, so get rid of that. And we're going to change date entered into date hired. So put date hired inside of there. And other than that, everything else is exactly the same. So let's just come in here and click our lightning bolt and then come up here where it says refresh all. And now we can see the salesperson has been properly entered. You can see here an example of different table data, and this is going to be specific to, we're running a shoe store in this example in this tutorial, so this is going to be a representative that this is going to be a business shoe, this is going to be the supplier, the specific name, the individual size, as well as any color, names, discount, tax rates, and quantities available for the individual shoe types that we sell. And you can see right here that duplication is a sign that the data should be in its own table. So what we're going to do is create a table called product type, which is going to be associated with name, either business, casual, or athletic. So we're going to create that product table right now. We can just come in here and we can come up and create a new query if we would like. So file, new query tab, there it is. So we got that guy inside of there, and let's go and create it. So we're going to say create table, and this is going to be product type parentheses, and then what we wanted to have in here, it's going to represent business, casual, or athletic. So the name is either going to be business, casual, or athletic. Variable number of characters, 30 should be enough, and we're going to say that it must have a value, so not null. And then what are we going to do after that? We're going to give it a unique ID, which is going to be this guy right here. So let's just copy that out of there and paste that inside of there. And that's all we need to do. And then we can come in and click on our little lightning bolt and come over to tables and refresh all. And now we can see product type is right here and everything's looking good. You can see an example here of our sales orders, which once again, we got from that invoice real world thing that we worked with previously. So basically what I'm going to be putting inside of here for each of the individual sales orders is the item ID, the quantity, discounts, whether it was taxable or not. You can see another example of a data type here, a Boolean, which is going to be either true or false, and the falses are going to be represented with the value of 0, and 1 and anything else is going to be considered true. You can see I went and put default inside of there. You can also see I defined a decimal. This is going to represent the individual customer database or customer table that I defined. This is going to represent the salesperson that was involved in the sale, the time in which the order was processed, purchase order numbers, credit card numbers, and all of these different guys. But whenever you look at this gigantic table, you're going to see a lot of problems, and this is where we get into better organizing data so that it is easier to work with. Tables, as I have mentioned previously, should not contain duplicate data. So for example, if we had individual items ordered all in one table, as well as salespersons and purchase order numbers and time of sales, as well as 4 different pieces of credit card data repeated over and over again, this is going to cause us some serious problems. So what we need to do instead is to take this gigantic sales order and break it into smaller and smaller pieces so it's more easy to work with. So one thing that I can do here is go and create another table called sales item, and we're going to link these 2 tables using both a primary key right here as well as a foreign key, which is going to be right here. Then what I can do is break out item ID into its own table, as well as quantities and discounts and taxation information, and be able to easily work with these and avoid duplication, which would have occurred in our sales order if we didn't break this individual sales items out into their individual pieces. And just remember that primary keys are unique identifiers, while foreign keys are going to be primary keys that are in another table. So what I'm going to do is come out here and define all the individual pieces that are going to be representative of my individual products. So I'm going to come in and I'm going to call this product instead. And after that, let's just get rid of, well, I'll leave the primary key inside of there. So for my products, I'm going to have type ID, which is going to store either business, casual, or athletic inside of it. So I'm going to call that type ID int, and it's going to be unsigned and not null. And where do I get that from? Well, this guy down here. This is product type, see, unsigned, and that's going to be primary key. Obviously, this isn't a primary key, however, but that's how I'm referencing that. This is going to be a foreign key, and I just need to type in type ID to reference that that is a foreign key, and then references product type and ID, which is the specific part of the product type table that we are referencing. Then my product, of course, is going to have a name, which is going to be a variable number of characters that I'm going to say is 30 in length, and it must have a value. What else am I going to have? Supplier. So this could be like, the name is going to be like the Speed Force, and the supplier is going to be Nike in this example. And I have no idea if Nike has a shoe called the Speed Force, but I think you get the point of that. Again, this is going to be not null for supplier. Then I can have a description that goes and explains what I'm working with. I need a blob, a bigger number of characters to describe the shoe. So I'm going to use the blob data type. And then I'm going to have a primary key just like I did before. And click the lightning bolt. No errors down here. And if I come over to tables and refresh, now you're going to see that I have a product. And you can see all the different data types that are stored there. So now let's create our other individual pieces. So I want to come in and create an item type. And basically this table is just going to describe just the quality of an item. So it's going to have a reference to the product ID, as well as the size, color, a picture, and a price. So that's all of those things. So let's just get rid of all this. And then I'll show you here in a second how these are all going to link together. So I'm going to link to product ID, int, unsigned, not null. And again, define that this is a foreign key that I am referencing, which is going to be product ID. This is referencing this right here. And then it's going to say specifically that it references the table, product, and the individual column ID in it. And then I'm going to list all the individual things that I want to store in here, like the size of the shoe, not null, color of shoe. That's going to be a variable number of characters, which is going to be 30 in length as a max. Again, not null. Picture. I'm not actually going to store a picture, but I'm going to store a URL that's going to link to a picture or a place on my machine, my server, where I'm going to be storing those pictures. So you don't store the actual picture, you store a link to it. Of course, we're going to need a price, and this is going to be a decimal as well. Well, actually, the picture should not be. This should be a variable number of characters. Let's copy this, throw that there. And then this is going to be a variable number of characters. And I'm going to make this really long. I'm going to say 256 in length, not null. And I could go and give it a default value, but whatever. I'll just keep it the way it is right there. Price, and I'm going to have that be not null. Okay. So you can see I'm breaking up the descriptions of all these individual tables into individual pieces. So this is going to be an item to specific information. Click that, tables, and refresh all. And now you can see that item is right here and all the data types that are defined for it. Now I'm going to create my sales orders. So come in here, get rid of all of this. And this table is only going to have information that's going to be pertaining to the order. And it's not going to contain information about products and prices and all those other different things. And basically what I'm doing with this sales order table is simulating two people agreeing to do business. So what am I going to want to store in that situation? I'm going to want to store the time of that event, a purchase order, and a means of payment. So I'm just thinking through the whole entire process. So I'm going to say sales order, and then what am I going to have? Well, I need to define the two people that are doing business. So we're going to have customer ID, integer. It's going to be unsigned, and we must have a value for it. What else am I going to have? Well, I'm agreeing that two people are doing business, so I'm also going to have a salesperson ID, which again is going to be an int, which is going to be unsigned and not null. And then I need to reference that these are foreign keys. So foreign key, and then say customer ID is going to be associated or is going to references the customer table and the ID inside of it. Then I'm going to do the same thing for my salesperson. So let's just copy this, paste it inside of there, and change this to salesperson ID. This is where that comes from. So I'm just going to copy it, paste it inside of there. And then it's going to reference the salesperson table. So let's just go and get this. Paste that right there, and ID specifically in the salesperson table. So if you want to make sure this is what I'm referencing, that's going to be the foreign key. That's where it's coming from, and that's how I'm doing it. What else did I say? Well, remember, we're simulating two people agreeing to do business. Well, I'd like to also, in that situation, know when the order was taken. So time order taken. And this is a time. So what we're going to do is give it the timestamp data type, not null. We're going to want to track the purchase order number because a purchase order was written up and each purchase order has a number. So there we go. This is going to be an integer and it's going to be not null again. Then we're going to have a credit card being handed over. So credit card number. I'm going to have this be a variable number of characters, 16 in length, not null. What else do we need to know about credit cards? Credit card expiration month. This is going to be a tiny int because of how small the number is. We're also going to have credit card expiration year. And this is also going to be a tiny int, not null. And then each credit card also has the secret code. So credit card secret code. Again, this is going to be a tiny int, not null. Then we're going to have name on card, variable number of characters, and let's say I want this to be 60. And again, not null. And then we have our primary key. All right. And if we typed, credit card, let's go in here and make sure we typed everything in right. Expiration month, credit card number, purchase order number, time order taken, and all of those individual pieces, and everything looks good. So let's go and run it, or create it, I mean. Down here, there's no problems. Come up here to tables, refresh all, and now we have our sales order as well. And you can see all that information right there if you want to pause your screen. If we do, of course, make an error, I will show you here in a minute how to go and fix and alter the tables. All right, so we have our sales orders. Now we want to have our sales items. Just want to review exactly how these are going to relate. We're going to have our individual product type. That is going to have an identification number, which is going to be referenced in the individual products. So this is going to be business, casual, or athletic. That is going to be referenced in the product table. its ID for the products, which have the name, supplier, descriptions, are going to be referenced in the item table. So that's primary key is going to go to this foreign key right here. The items have the size, color, picture, and price. That ID is going to be referenced in the sales items, and then the sales items are going to be quantity, discount, taxable, and tax rate. That ID is going to be referenced in our sales orders. So that just means the only thing left is to go and put our sales item information in. And so that you didn't have to watch me type all that in again, I went and created it ahead of time, and this is the sales items. So basically, each item that is part of an order is going to go in its own table, and it's then going to be linked to the order with the sales order ID. And this is just going to simulate picking up a quantity of an individual item with a certain discount and a certain tax rate, and the item itself is hidden in the item table. And specifically 100% defined specifically there in a way that makes it easy to refer to it just with its ID. And the reason we're doing all this is if I were to go and list color, size, or anything else, that's going to break that ability to consider items in a self-contained way, which would be a bad thing, which is why we're breaking the tables up the way that we are. And whenever you are creating a database design, it's very important to consider that the data in the database be just that, data. It's often better to perform calculations outside of the database versus storing those calculations, such as total sales amounts and things like that, which I will show you here very soon how to do. So let's say now that we have all this created, well, first off, I have to go and actually create my sales item table and come over here and refresh, and there it is. So sales items, and now we have all of our individual different tables for our database set up. So let's talk about altering tables, because I said that we can alter tables. Let's come in here to, well, we don't need any of these, so yeah, don't save that. All right, so we're inside of here. How do you go about altering a table? So let's say that I want to add a new column. Well, what I would do is say alter table, and let's say that I want to add it to the sales items table. What I would do is, let's say I wanted to add the day of the week that this sales item was created or whatever. I could do add day of week and say that it's going to be a variable number of characters, 8 in length. I would then follow that up with a semicolon and go and create it. And if I did, let's come over to tables, refresh all, sales item, click on sales item, and you're going to see day of the week is right there. I could also come in and modify that column. So I'm going to again say alter table, sales item, modify. So instead of add, I'm going to say modify, day of the week. And let's say that I want it to be a variable number of characters that are 9 in length, and that I want to mark this as not null. Execute it. Again, you have to come in and refresh it. And if I go into sales item, you're now going to see that it's variable number of characters 9. Okay, so that's another way to alter. Another thing that I could do is, let's say that I would want to come in here and drop this column. Let's decide I don't like having weekday inside of there after all. Well, I could just go in alter table, sales item, which is the table name, and drop column and weekday. And execute it. And now if we come in and refresh this, we're going to see that inside of sales item, we no longer have weekday. We do have day of the week. So let's go and get rid of day of the week. Execute that and refresh it again. Sales item, and now you see it's gone. All right. Well, what would happen if we would like to come in here and let's create another table? So let's create a table and let's call this transaction type. And let's do all kinds of funky things with it. So let's say we have a name, variable number of characters, and 30, and not null. Let's say we have payment type, variable number of characters, and have this be 30 as well, not null. And then it's going to have a primary key and auto increment, and this will be the primary key. Close that off, and let's create that table. Refresh, transaction types right there. We could then come in and rename our table if we would like. So just go rename table, transaction type to, let's say we want it to be called transaction instead. Execute, refresh, transaction type became transaction. We're also going to be able to create an index. And let's say we want to create an index based off of a single column. We can say create index transaction ID on transaction name. Create that. We could also come in and create an index based off of two columns. So let's change this to transaction ID 2 on, and then say transaction name as well as payment type. Execute that, and we created another one. We'd also be able to come in here and delete data that is in a table just by saying truncate table transaction. There's nothing in it right now, but that doesn't matter. That'll work. And then finally, we could drop the table all together just by saying drop table transaction, and it's gone. You can see over here. All right. So there you go. There's a whole bunch of different ways in which we can alter columns and tables. And now I'm going to show you how to alter tables inside the workbench. Now you're also going to be able to view as well as alter tables just by coming over to your table and right-clicking on it and then coming down to where it says alter table. You can see then that it gives you all the information about your table. In this situation, it's our customer table. You can change the name just by clicking on it and then typing in a different name. You can change all of the different constraints as well as the data types. You can come in here and mark this as a primary key. This stands for not null. This means unique. This is binary. This is unsigned. This is zero fill, which means it pads the displayed field with zeros. This AI stands for auto increment. This is going to be generated, which means that it contains functions that auto create values. And then you can also put a default value inside of here. You're also going to be able to double click to add columns as well as right click to delete selected pieces of information. And of course, if you make any of these changes whenever you're done, come down here and click on apply to apply those changes. But we're not going to change anything right now. Instead, I'm going to show you how to both insert as well as update and delete database values. So let's click on our query tab once again. I'm going to first off go in here and insert some information into our product type table. To do so, you just go insert into whatever your name is for the table you want to insert into. This is going to be product type. You're then going to list the pieces of data you want to enter by their name. So I'm going to say I want to enter name and ID. Follow that up with values, and I'm going to put this on the next line so it's easier to fit everything. And then inside of parentheses, what you want to put in. So I'm going to say business, and then for the automatically generated primary key, you just put in null, and it automatically generates it for you. Whenever I do that, I can execute it, and then that piece of information will go inside of there. I'm then going to also put casual inside of there, and we'll look at the information here in a second. So I'm going to go casual, and again, click on that, and then athletic is going to be the last piece of data, and go and execute that. Now we would be able to come in here and go select and a star from, and product type is the name of our table, and execute that. Whoops, product type. I said product type and then typed in product ID. And whenever you do, you can see our pieces of data, which is casual, business, and athletic, and the IDs that were auto created for us. Well, you can also input data in without listing over and over the column names as long as you put them in order. So let's just go out of this and go back to this part. So we can say insert into, and this time I'm going to put individual products inside of here. And then I'm going to put values like this. Let's bring values up here. And as long as I input them in the correct order, I don't need to go and list the column names. So I went and created this information ahead of time, pasted it in there. So now you're going to see if we have product here, here's product. So there's going to be the type, which is either going to be business, casual, or athletic. The name, the supplier, the description, and ID is auto-generated by putting in null. You can see I put product types, all the different product types, the individual name, as well as the supplier, a description, and then null at the very end. And then you're going to separate all those with, of course, parentheses around all the data, and then commas. And then at the very end, put a semicolon. And I have all of this available in the description. You can get all of this stuff. And we execute it. And then what we can do is do a select all on this and select everything from product like that and execute it. And you can see all those individual pieces of data that are inside of there and all of the auto-generated IDs. All right, so pretty cool stuff. Now I'm going to do the same thing for our customer information. And I actually auto-generated all this stuff using a Python script, which is also in the description if you want to go and get that, if you want to generate all these different pieces. Or like I said, I have all these commands inside of here. You can see right here, I'm going insert into customer, first name, last name, email, company, street, city, all of the information for all of our individual customers, all surrounded with parentheses with a comma at the end to separate all of the customer data, semicolon at the very end. Execute that. Then we can come in and go select everything from the customer table, execute it, and you can see all of our customer information is being stored in the database as well. All right, so neat stuff. Now I'm going to do the same thing for our salespeople. So once again, come in here, paste that inside of there. Here's insert into salesperson, all of the individual pieces, and at the very end, put a semicolon. Don't have as many salespeople, only have 5 of them. And we can come in here, boom, and then go and select everything from sales person table, and that's all been properly inputted as well. One thing that I have noticed is with my sales order table, whenever I come in here and click on that, if I come down here with my purchase orders, the way I organized this was the purchase order numbers are going to be the year, month, day, as well as the time the purchase took place. Well, I actually need a bigger number than an integer inside of there for that. So what I want to do is come in and alter that table. So I'm going to say alter table, sales, order, and I want to modify the data type. So I'm going to say purchase order number, and I'm going to change it into a big integer that's going to be unsigned and not null. And I can put this on a separate line if I'd like. So purchase order number, which was an integer right here, I'm going to make it into a big int instead that's unsigned and not null. Execute that. You can see down here, response is where there would be an error message if there was an error, but there isn't. So we come in here and we can refresh this. And now you can see it's a big int and it's going to be able to hold my gigantic purchase order numbers. Had another error here also with my sales order in which I was trying to auto-generate the secret codes. So here's credit card secret code. Well, I knew that the secret code could be up to 999, but I didn't set it up that way because it's set up as a tiny int. I need that also to be altered. That's also in sales order. So I'm going to go sales order, modify, and then I'm going to say credit card secret code, and I'm going to change that into a small int. So let's change it into a small int. Unsigned, not null again, and we can go and execute that. And we can see if we come in here and refresh this, refresh all, whoops, let's come in sales order, and you can see that that's now a small int right there. Okay, so a couple little changes that we make as we create our database, totally normal. Now what I want to do is come in and insert my individual items. And there all those are. So insert into items and the values. If we click on item, you're going to see here size, color, picture, price, ID. And you can see right here all of those individual pieces of data. Again, surrounded with parentheses, separated with commas, and make sure that the very last one is a semicolon, which it is. And then we can execute that. And we'll see that item is also going to be set up properly. So you can also type in these commands like this. It's just kind of a can be a problem. So harder to read. Select from item like this, run it, And there's all those items. I can then come in and put in my sales orders. So there's all that information, whole bunch of information. And sales orders, of course, is going to be customer ID, salesperson ID, time order taken, purchase orders, all that information. That is all right here. Again, just make sure that I have a semicolon here at the very, very end. I do. And there it is. And we can go and execute that. And then we can copy sales order and delete that and select everything from sales order. Okay, and whenever we put through those sales orders, we'll be able to see all of them here. Just a special note here, all of my IDs start at 201. Whenever this is created, I accidentally hit this twice. So it goes from 201 down to 300 for the IDs. But everything else there is okie dokie and very good. Next thing I need to do to finish up all of my input is to input my sales items. And there are all the sales items, and specifically sales items. And this is item ID, sales order, quantity, discount, taxable, sales rate, and then the primary key, which is auto-generated. There's all of those. And this is the reference to the sales orders. As you can see, they're all in the 200s. And go down to the bottom and throw a semicolon and then execute that. 200 rows were affected, so that's good stuff. And sales items is what we just changed here. So let's just copy that, get rid of this, and then go select everything from sales item just to verify that it went through. And it did, and everything looks good. And there we go. Now we have all of our data inside of our database, and now we can go start working with it. Okay, so we're going to be able to define different ways that we want to look at our data. One way is through the use of conditional operators, and equals is just a simple equal sign, less than, greater than, less than or equal to, greater than or equal to, and not equal. There's actually two ways to define not equal. So let's say we wanted to say something like we wanted to show all sales with a discount greater than 15%. How would we do that? Well, we would say select all, that's what the star stands for, from sales item, and then we would define our condition where discount is greater than 15%, and there we go. And if we execute it, you're going to see all of those sales, and you can see the different discounts right here. So lots of discounts were handed out. We're also going to have what are called logical operators, which are going to allow us to combine conditions, and those are going to be and, or not. And let's go and let's see what one of those looks like. So let's say we wanted to find order dates for all orders in December of 2018. How would we do that? Well, I'm going to say specifically that I'm interested in the time the order was taken. So I'm going to say time order taken and from sales orders. And then I'm going to say where time order taken, let's just throw this in here like that, is greater than, and then I'll define my date, which is going to be 2018 12-01, and I'll say time order taken again, less than, and then we'll go and do the same thing with our date, and we can throw this on the next line, and throw this here, and then change this to 31 instead, and then we can run it, and you'll see that there were 2 actual orders taken. You'd also be able to list out any other additional information. So inside of sales order, we could say, for example, customer ID. So if we wanted to see what the customer was that did that, we just tack that in there with a comma in between them, run it, and there you can see the customer ID that matches up with it. You're also going to be able to do the same type of thing by using between. So you can say time order taken, and then inside of here, go between, and then get rid of that space, this guy right here, and get rid of this, bring that over here, and then throw that up there, and then run it again, and you're going to see you get the same results. So 2 different ways to get the same information. Order by is going to be another command we can use to determine the order of the information that's being output. So we could go do our discount again. Here it is. So we can say that we want to get everything. So that's going to be star from sales item where our discount is greater than 0.15. And then we could say order by and discount. And if we execute that, you're now going to see that the discounts start off low and grow as they go up. So that's how order by can be used. You're also going to be able to, let's say we wanted to go from high to low. We just put descending inside of here, and now we can change that up. We're also, let's say we wanted to get just the top 5 discounts. At the very end of this, we could say that we just want the first 5 just by putting limit inside of there 5, and there those are. And then we could get the next 5 by just putting a comma and putting a 10 after that, and then we would get the next grouping. Okay, so more stuff we can get. We're also going to be able to come in here and combine data. So let's say we wanted to come in and get the first name as well as phone and state for everybody that lives in the state of Texas. So we could go select and concat and follow that up with our first name and then put a space inside of here, another comma, and last name. And concat will combine those two, or concatenate. That's what the word stands for. And another thing, we can do an alias. Let's say we wanted to list this as name in our output. We just put as name, and that's going to show up in the table whenever we go and execute this. We could then get phone and state, and then from customer, where state is going to be equal to Texas. There it is. So that could be useful for a salesperson or something. And you can see right here, there is the name alias that I referenced. And then you can see the phone number and the state that is shown there also. So a whole bunch of those guys. We'd also be able to perform all sorts of different calculations inside of here using these queries. So let's say we wanted to go select and get the total value of all business shoes in our inventory, for example. We could go select and product ID, and then go sum and price, and we could change this. So we can use alias again as value from, use the item table where the product ID is equal to 1, and you can see we got our total right there. Distinct is going to be another command we can use to help eliminate duplication inside of our results. So let's say we wanted to get a list of states we have customers in. We could say select and then distinct state from our customer table. And let's say we wanted to order them alphabetically, order by state, run it, and there we go. Got the 5 states where we have customers. We could also come in and say we wanted to get all the states where we have customers, not including California. And to do that, we'll say we would do all of our conditions inside of where clauses. So we'll say state not equal to California. Run it, and then we just get all of our states excluding California. The in phrase can also be used to test if a value is inside of a list. So we have select distinct state from customer, and then we'll say where state in, and we'll say that we just want those states that match with either California or New Jersey. So we can say, do we have customers in California or New Jersey? And it comes back, and you can see that yes, indeed, we have both. All right, so there's a couple different ways we can use queries, and I'm going to cover many more, but now I want to talk about getting data from multiple tables. Now we're going to be able to get results from multiple tables with either inner joins, outer joins, or unions, and I'm going to show you examples of all of those. And the most common join is the inner join. That's what you're going to use most of the time. And with it, you're going to join data from 2 tables in the from clause with the join keyword. And then again, we're going to have an on keyword, which is going to be used to define the join conditions. So let's say we wanted to do something like get all items ordered ever and then sort them by ID while listing their price. So we could say select item and ID and price from, and we'll say item, and then we want to do an inner join so that we join the items table with our sales item table, and our condition is going to be defined after on, and the condition is going to be item ID is equal to our sales item, which is item ID. Okay, and you can see how we're able to use primary keys and foreign keys to join data. And then we'll say we want to order them by the item ID. Run it, and there you can see. And there is all of our pieces of information for our item ID as well as the price for that. And that is just the beginning of the usefulness of joins. We're also going to be able to use the join condition to find IDs that are equal in the tables item and sales item. And in this situation where we join tables while checking for equality between a common column, this is called an equal join. We're also going to be able to define multiple different join conditions with logical operators. So we have item ID and price from our item table and our sales table. Let's say we wanted to come in here and keep this part right here where we're joining using the foreign key and the primary key. But we also want to say, and the price is greater than $120, for example. Run it, and there you can see that. But now we're going to get into some funky stuff, because what I want to do here is actually show you how to join three tables. So let's say we wanted to get the orders, quantity, and the total sale. So we could say select sales order, and we'll get our ID. Follow that up with sales item quantity and the individual item price. And then we want to say sales item quantity times the item price. And we'll go and create an alias, which is going to be total. And we'll say that we want to get that from the sales order table, which we will join to our sales item table. And the condition is going to be that our sales item sales order ID is equal to, whoops, accidentally put a space inside of there, is going to be equal to our sales order ID. And then we can do another join. And we'll say join item on item ID equal to sales item ID. And then let's order this by our sales order ID. So now we're getting into some really good stuff. And if we run it, you're going to see here, quantity 1, the price of the individual item was $139.26, and the total, of course, is the same. And then as we add in additional information here, we have quantity 2. You can see the total sale and how they match up with the different order IDs. All right, but as we go, we're going to get into even better stuff. But one thing that I left off are the arithmetic operators that we have. So of course we have plus, minus, subtraction, and integer division, as well as regular division. And modulus is just, it provides the remainder of a division. And we'll see more on that, and we'll do more with them as well. Another thing that's going to be available to you, but it's kind of frowned upon, and you're not supposed to do it, but you can do it, so I'm going to show you. Is actually defining the on condition with where instead of on. So you could actually come in and go select item and price from our item table as well as our sales items table. And then you could say where item ID is equal to sales item dot item ID and price is greater than 120, and order by item ID, and run it, and you can see you get those same types of numbers that we saw before. So just another option. And that's just the beginning of inner joins. Much more is coming, but now I want to talk about outer joins. Now, an outer join is going to return all of the rows from one of the tables being joined, even if no matches are found. So there's going to actually be two of them. A left outer join is going to return all rows from the table being joined on the left, while a right outer join is going to return all rows from the table on the right. Now, it's common practice to avoid right outer joins, so I'm just going to use left in this situation. So here, let me just give you an example. So we can just say select, and let's say we want name and supplier and price from product left join with item. So here's the product table and the item table, and we're using a left join here. On item, define our condition for how this is going to match up. So product ID equal to product ID, and then order by name. Whoops, name. There it is, and run it. And there you can see all of our results once again. There is our name, and there's the supplier, and there is the price for the joining of the product and the item tables. All right, so quick example of an outer join. We'll do some more later on, but now I want to talk about cross joins. Now, a cross join is going to include data from each row in both of our tables. So what I want to do is grab information from the item as well as the sales item table. And this is going to produce a whole ton of different results. And because there is no join conditions, whenever you're using a cross join, you're really rarely going to see them, but I just want to cover it just so that I can. So what you do here is you say select sales, order, ID, and quantity, and product ID from item table, and then you type in cross join, that's where the name comes from, and sales item, and then see there's no conditions here, you get it all. Order by and sales order ID, and if we execute it, there you can see there's every single thing. All right, so that's a cross join. And why don't we talk about unions? Basically, a union is going to combine the results of two or more select statements in one result. Now, one thing that's important to understand with a union is each result must return the same number of columns and data in each column. And on top of that, the data in each column must have the same data type. So let's say we wanted, just as an example, to send birthday cards to all our customers as well as our salespeople for the month of December. How could we do that? Well, we're going to say select and first name and last name and street and city and zip. See if I can spell zip right. There we go. And birth date. And we're going to do this from the customer table, where month is how you get the month only out of, let's see if we have, this is customer, right? You can see here is a birth date, and there's a date. That's the data type. If you wanted to just get the month out of it, you could also use this with timestamps. You could just type in this, and then birth date equal to 12. And see, here is where union comes in. It's going to allow you to combine data from two different selects. So this is almost exactly the same. So let's just copy this and paste this in here. All of this is exactly the same, except we're going to change this to salesperson. And everything else is the same. And then we'll end this off with order by birth date. And run it. And there you can see all of the customers as well as salespeople who have birth dates in December and when those birth dates occur. All right, and all that other information. So neat stuff. So that's how unions work. They allow you to basically unite two select queries. On a side note, probably also should talk a little bit more about null. You're going to be able to go and check for null. And null is used whenever a value is not known. So what we'd be able to do here is say something like select product ID and price from the item table where price is equal to null. and nothing comes back. That's the reason why, is because all of my products have prices assigned to them. You're also, however, going to be able to come in here and just change this to is, and that's going to give you the same result. But you can also come in and go is not null, and that's going to give you some returns here because now everything has prices. All right, so just a little trick for using null and checking for null and so forth and so on. And now I want to talk about like and regular expressions. Okay, so like is going to be used to search for simple string matches. So let's just give you some examples. Let's say I wanted to find any customers whose name begins with an M. So I can say first name and last name from customer, and then where first name like, and then follow that up with M, and then I can put a % inside of there, and that is going to give me my matches. And you can see there is a good number of them. Okay, another thing, well, basically what the % is going to match for this guy is it's going to match for 0 or more characters. You're also going to have an underscore, which is going to match any single character. So let's go and do something similar for this. Let's say I want to find any first names that begin with the letter A. I can come in here and say A like that. And then let's say I want to find if there is an Ashley. So that would be A-S-H-L-E-Y. I don't know if there's an Ashley, but we'll find out. Yes, there is. So you can see you do an underscore for each individual character. And that's basically what you can do with like. You could, however, also, let's say we wanted to return all customers whose first name begins with a D or whose last name ends with an N. Well, we can do that. So we'll say first name, like, and we'll throw a D inside of here, and %, and we were going to say or, and then last name, like, and then we'll go %, N. And I think I did. Oops, I have to put that there. Okay, so we got those. And let's run it. And you can see there we go, all those matches. All right, so that's basically what like's going to give you. It's going to give you the ability to match for 0 or more characters or match for any single characters. Then we get to regular expressions. They are a lot more complicated. And I'm not going to be able to cover everything, but I have an entire tutorial just on regular expressions, but I am going to give you some examples, and I'm also going to give you an overview of what is available to you with regular expressions. All right, so here are some regular expression patterns. A period is going to be able to be used for any single character, just like with like, an underscore is any single character. Well, period's the same. Star is going to match for 0 or more of what comes before it. Plus is going to be 1 or more. The caret symbol is going to represent the beginning of a string match that you're looking for, while a $sign is going to represent the end of a string. Anytime you want to match, like for example, the characters A and B, just put them inside of brackets. And if you want to match anything except A and B, put the caret symbol inside of there. This guy's going to match all uppercase letters. This is going to match all lowercase and all numbers. If you put a caret in there, it'll match anything except those things. And if you use the curly brackets and N after something, it's going to match N instances of whatever it is. So let's say you wanted to look for mall and you wanted to match for 2 L's. Well, you would have L, and then you'd have inside of curly brackets 2. So it's going to match those 2 L's. You can also match between an M or N instances. So it would match for mall or whatever else, pal, I don't know. And you can also use this or symbol expression to come in here and match for one thing or another thing. So here's some examples of using regular expressions. Let's say we wanted to match for a first name that starts with the letters M and A. We could just go in first name. Again, we're going to use the customer. And then inside of here, instead of like, we're going to put this here. And then we will say where first name, regular expression, and then symbolize that we're looking for the beginning of the string. That's what that caret does. And MA like that, and then like this, and then it'll give us all our matches for names that start with MA. We're also going to be able to get, let's say we wanted to get the last two letters be EZ. Well, we would put a $ inside of there and nothing comes back. Don't know why, but that's how you would match for that. Oh, I know why, because let's change this to last name. Now it'll work, and there we see all the Martinez's that pop up. We could also come in and match last names that contain just certain letters. So let's say we wanted to look for EZs or put an or sign in there. SON, run that, and you can see all those show up as well. And we could also come in and say like a $ inside of there, and you're going to get the same type of results, but just wanted to run that. So you can combine all those different little tools and patterns. And you could come in here and say that you wanted to match for last names that contain letters W through Z, for example. Put those in brackets, and there you go. And you could do last names that have at least 2 L's inside of them. So go like this, and like that. And whoops, only put that there. Okay, and run it, and you'll see Williams comes up. So just a whole bunch of different things. Like I said, in the description underneath, I will put a link to my regular expression tutorial to give you an overview. I could do an hour on regular expressions or more. So that's just an overview of how you can use regular expressions in MySQL. And now what I want to do is show you some ways to summarize your results. Okay, so group by is going to define how the results are going to be grouped. And we have another function called count, which is going to return the total number of records that match. So what we want to do here is use group by to return a single row for each unique value. And like what we're going to do here is say or look up how many customers have birthdays in certain months. So we'll go select and month and birth date, and there's tons of these functions. I'll show them to you after I cover group by. So I'm going to say as month, that's just going to say what is going to be displayed at the top of the table. And let's say we want to count all the individual amounts. That's going to allow us to do that, and we'll name this amount. Then what we want to do is we want to take this from our customer table, and we want to group, go down here, group by month. So it'll just have everything grouped into all the individual months, and order by month. Okay, so that's going to show us this, and you can see right here that in the month of January we have 1 customer, and so forth and so on for all of the other months of the year. All right, so that's one way to use group by. Later on in the tutorial we're going to get even more complicated stuff. But let's say we wanted to find those months that had at least 2 or more customers with a birthday in them. Well, to do that, we have another command called having, and you have to put having after group by. So we could say something like having amount greater than 1 and run it. And now you can see it's only giving you the results where we have 2 or more people having birthdays in individual months. So pretty neat stuff. And let's go and do another thing. It's kind of interesting to finish up working with group by. Let's say we wanted to get the total purchases from each company. How would we do that? Well, you go select and customer ID and the company involved, and we want to count them. So like that, and we'll call this as purchases. And we're going to get this from our sales order, and we're going to join this to our customer table, and we're going to do that using our condition here where the customer ID is equal to customer ID, and then we will group by customer ID, and run it. And you can see all of the individual companies and how many purchases each of those companies made. So pretty neat stuff. It's just so easy to work with data using SQL if you know how to use it properly. And now what I want to do is jump over and show you some of the other aggregate built-in functions. Alright, so here is a whole bunch of them, and I've been using them in my statements, so I think you'll be able to pretty easily figure out how to use them, and as the tutorial continues, I'm going to use a couple of these. So you can see we can get the absolute number, there's all kinds of trig functions, you can average, and by averaging, we would average the column name. Ceiling is going to round up. Degrees is going to convert from radians to degrees. You can see that there's exponent. Floor is going to round down. There's two different log functions. The mod stands for modulus, which gets you the remainder of a division. Pi is built into MySQL. We can go and find the power of different values. We're going to be able to convert from degrees to radians. You're going to be able to generate random values from 0.0 to 1.0, and then you can go and add or multiply those values to get all kinds of different random values. You're going to be able to round. Basically, it's going to round down. If it's less than like for example, 4.5 is going to turn into 4, and if it's 4.6, it's going to turn into 5. That's what the round function does. We have square root, we have standard deviation, and a whole bunch of other different things, but those are the general functions that I personally have not used in this tutorial or don't plan to use. So there you go, a rough overview of those. And now what I want to do is talk about some other different aggregate functions and give you some examples on how they can be used. So just to start off here simple, let's say that I would want to sum the prices of all my items that I have. I could just go select and sum and price and from item. And that's going to run, and that's going to give me my total inventory value of $7,231.58. Okay, so let's go and get even more things. So let's say I want to use a whole bunch of these aggregate functions. And an aggregate function is just a function that returns a single value from multiple parameters. And it doesn't have to be multiple parameters, it can just be one. All right, so we could say as item, and I'm counting all of my items that I have. I'm just going to show you a whole bunch of them. I'm going to sum the price as value. And what else can we do? I'm going to show you rounds. And what I'm going to do is go and get the average price divided by 2 decimal places, or I want to use 2 decimal places in my result. And then I'm going to say that's called average. And let's go and get the minimum price as well. And we'll call that min. Do a couple more. Let's also get our max price. And this is for all my different items that I have in my items database. And let's just do from item. Okay, so that gives me a rundown of my inventory. And you can see right here, I have 50 items, total value, the average cost, the minimum cost, and the maximum cost. All right, so that's a rundown of aggregate functions through examples as well as a list. And now I want to talk about working with views. All right, so views are select statements that results are going to be stored in your database. So what I want to do here to give you kind of a real world type of example is I'm going to create a view that contains our main purchase order information. So what I'm going to do is I'm going to say create view purchase order overview is what I'm calling this view. Purchase order overview as, and then afterwards I'm going to put in a select with a whole bunch of different joins to combine a whole bunch of data from a whole bunch of tables. So what I'm going to do is I'm going to say that I want to get my purchase order number from my sales order table. So purchase order number. This is going to be like a real useful thing. I'm also going to get whatever the company is that made that purchase. I'm going to say that I want to get the quantity that they bought. So sales item and quantity. I'm going to get the product supplier. So that's going to be like Nike or whatever. And I am also going to get the individual product name. So product followed with name. I'm going to get the item's price. And I am going to go and get the quantity and multiply that times the price to get the total. So I'll go sales item underscore item, and that's going to be quantity, and multiply that times the item's individual price, and I'm going to give that an alias of total. All right, so I think that's pretty, you know what, let's put even more in here. I'm also going to go and put the salesperson that made the sale into this. So concatenate, and I'm going to put salesperson and their first name and salesperson and their last name. And let's give this the alias of salesperson. Okay, now to get that, I'm going to join some tables. So I'm going to say from sales order table, I'm going to join sales item. So those two tables go together. And how are they going to go together? They're going to go together by comparing the foreign and the primary keys. So I'm going to say on sales item, go like that, and sales order ID, sales order ID being equal to the sales order ID. And then I'm going to join even more. So I'm going to say join item, and how am I going to join it? Well, I have to give it a condition. Again, it's going to be the primaries to the regular foreign keys. So I'll say item ID is equal to the sales item ID, and let's join some more. So it's just going to keep going. I just wanted to give you some real world examples. From now on, the rest of the tutorial is going to be pretty much real world stuff. I'm also going to need to join our customer. So join customer to all these tables, and how I'm going to do that is going to be on sales. So anytime you want to join two different tables, what you're going to need to do is find those foreign keys and primary keys that match up. So this is going to be sales order, let's get out of there. There we are. Order dot customer ID equal to customer ID. And I'm also joining the product table. So this is a really complicated guy here. I'm also going to go product, and how am I going to match those up? Guess how. I am going to go product ID equal to item dot product ID, and then also I have to join the salesperson. So I'll say join, and this is going to be salesperson. Geez, I'm running out of screen here. So there's salesperson, and on, this is going to be salesperson dot ID equal to sales order salesperson underscore ID, and then as a final thing I'll say order by purchase order number. All right, so that is a long query that's going to give us some crazy stuff, and it's going to store everything in a view. So let's run it. As long as I didn't type anything wrong, it should work, and it looks like it did. So let's come in here and just refresh all, and now you're going to see over in views that there is a view, and there it is right there. You're also going to be able to see our different results here if we go and look at it. And how we're going to do that is, let's just select all of this stuff, and to see our purchase order overview, which is going to be stored in the database, and it's going to update also as other parts of the database update on its own. So I'm going to say select everything from the purchase order overview like that, and run it. And whenever you do, it's going to give you this view with all of that information that we requested. So pretty neat stuff and very, very useful. And that's how we go and create views and how they work. All right. Now you're going to be able to drop this view if you decide you don't want it anymore, just by coming in and saying drop view, and then follow that up with whatever the view is you want to drop, but I don't want to do that. And it's also important to know that And as a side benefit to a view is that they are going to allow you to hide or change data in other tables while keeping the view the same. And this is beneficial in hiding data from users who shouldn't have access to it directly. And one thing, however, to be aware of is if you want a view to be updatable, it can't include the terms distinct, union, it can't have any aggregate functions in it, nor can it have group by or having. So knowing that, I need to change my view that I had previously, and this would be the new format of it. Basically, what I had to change here about this is I had to remove the aggregate functions because I didn't have any of the other issues. So that means I have to get rid of concat and all that stuff. Let's just come in here and go sales, fname. Well, I could do a concat in another way, but I'm just going to do it this way right now. So this is basically the way the view is going to look that is going to allow it to be updated. Like I said, I just removed the total aggregate. You can pause your video if you want to type that in, or like I said, all this is available for download for free. So this is the new one. So we can come in here and run that. Or actually, you know what? I have to go and drop the other one first. So let's do that. Okay, so let's get rid of this. And to purchase order overview, so let's go drop view purchase order overview like that. Run that, get rid of it, and then go in and create the new one. Throw that inside of there. Now run it. And now we have the new one. And now if we wanted to get that aggregate function like the totals and things like that, we still can. All we need to do is to come in and do something like select everything, and then we can add to it. So then we'll also say quantity times price as total from purchase order overview. And there we go. Now we got our same results. Whoops, you don't have to save that and run it. And you're going to see we get the same results that we were expecting. All right, so pretty neat stuff. And there's an example of how views work and some of the issues with them and how to solve them. And now what I want to do is talk about stored programs. Now you're going to be able to write programs that are similar to traditional programming languages. And there are different types of stored programs. There are stored procedures, and there are stored functions, and there are triggers and events. And I'm going to show you all these. Basically, a stored procedure can be executed by an application that has access to your database. So PHP can access it, basically anything can. And a stored function is going to be executed using your SQL queries like you keep seeing. Triggers are going to execute when either insert, update, or delete commands are executed, and events are going to execute at scheduled times. I'm going to show you examples of all of them. So what I'm going to talk about first is how to create a stored procedure that's going to let you get a list of customer company names. So how you create it is, first off, you need to define the database you're using. So I'm going to say use sales DB. So there's the database we're using. And then what you need to do is say drop a procedure if exists. If I already created a procedure with a name, as you saw previously, it's going to give me an error unless I say that I want to delete the previous and update it with the new stuff. So that's what this is going to do. So I'm going to call this get customers. That's the name of my stored procedure. So it's going to, if I change it, it's going to just say go and overwrite it. Then what you need to do is switch the delimiter like this, and I'm going to switch the common delimiter is with a semicolon. I'm going to switch it. As you see, every statement ends with a semicolon. I'm going to change the delimiter to 2 forward slashes, and this is going to allow me to use semicolons inside of my stored procedure. And then whenever I'm done, I'll switch it back. So now to actually create the stored procedure, you go create procedure, and you already saw the name of it, get customers, and you can pass values inside of here. So I'll say get customers. I'm not going to receive anything though to start off. And then begin is going to assign the beginning of where the procedure code is going to lie. And then you're going to do whatever you want to do. So I'm going to say select customer company from customer. Just do something pretty simple here. End that with a semicolon. And then we're going to say end and 2 forward slashes. And then at this point, I can say that I want to switch the delimiter back to semicolons. And then to call for this stored procedure to execute, I say call get customer. You can call this, outside of here, but I'm just calling it here so you can see it execute. And I'll run it. Whoops, get customers. There we are, and I have that the same. All right, good. Get customers, and you can see it gave us a list of all of our customers. All right, so neat stuff. And we're going to do way more complicated ones after this. Let's say that, for example, I'd like to create a procedure that returns inventory value based on supplier. A lot of this stuff's going to stay the same. Sales DB is going to be the same. Delimiter is going to be the same. Down here, I'm going to say get supplier value. So I'm going to say get, do it here too. Get supplier value. So supplier underscore value and create that procedure. So get supplier value. And then this guy's actually going to receive a argument, which is going to be the supplier's name. So I'm going to say in is defining that I'm going to be receiving information into this procedure. So I'll say the supplier is what I want to call it. And you have to define what the data type is going to be. So there's that. And then I want to declare a couple things inside of here. So I'm going to say I'm going to declare some variables that are only going to be used in this stored procedure, and they're going to hold results of a query. So I'm going to say supplier name, variable number of characters, 30 in length. You have to define the variable name as well as the data type for it. And you'll see how the data is going to be stored inside of it. I'm going to go and get price sum, which is going to be a decimal. That's going to be 8 potential total numbers with 2 decimal places. And then I go and issue my query, get the results, and store them. So select and product supplier, and I'm going to sum the item prices. And this is where you define where those values go. So product supplier is going to go in supplier name, and sum is going to go in price sum. So you just say into supplier name, this is where the results go, comma, and then price sum is where the other one goes. So throw that right there. Then I just continue the way I would always do it. I'm going to say that I want to get information from the product table and the item table, and then the condition, which is going to be that the supplier is going to be equal to the supplier that they passed into the stored procedure up here. See, this guy right there. And there it is. And then after that, I can output this information. And how you output information from a stored procedure is with using select. So I can concatenate or join information. So I'll say supplier name, and then separate everything with commas. And I'll say inventory value, $, and then after that I can say price sum, and then if I want to give it a custom title as output, for example. And that's everything I need to do. Oh, actually no, I'm going to go get supplier value. So I'll get all the values for whatever I throw inside of here, and I'm going to say that I want the total value of inventory from Nike. So there's everything, and if I run it, you're going to see Nike inventory comes back, and it has a total value of $21,694. So that is out of money in Nike tennis shoes. And now I'm going to show you some more stored procedures. Okay, so now I'm going to show you how to accept multiple values. And you already saw this in parameter right here. And what it does is it just designates a parameter expected to be passed to a procedure. But what I didn't tell you is that it's passed by value. And its value is only affected inside of the procedure. So that's important to know. So now we're going to create another procedure that's going to get customer birthdays. So let's just come in here and let's call this get customer birthday. And then of course we're going to put that down here as well in the procedure name. So let's throw that there. And then we're going to use an out parameter, and what it's going to do is pass values back to the code that called for the procedure to execute in the first place. So we'll come in here where it says in, and we'll just have this be the month. So let's just call it the month, and it's an integer. But then we're going to list a whole bunch of other different things inside of it. So we're going to also say out, and we'll say birthday month, also an integer, out, birthday day, also an integer. We'll go and get the first name, variable number of characters, and let's say it's 20. Out again, which is going to be the last name, again, variable number of characters, which is 20. And let's say that we want to call the customer to wish them a happy birthday. Let's go and get their phone number as well, variable number of characters, also 20. All right, so now that we defined all those, let's go and get all that information. So inside of begin and end, we're going to say select month, and we'll say birth date, and then we'll do day, and again, birth date, first name, last name, and phone number. And we're going to be taking this from the customer database, of course, so from customer, and then we'll say where month, birth date, is equal to the month that they passed in. So they'll be able to pass in a month, and it'll automatically send you back all the customers who have a birth date in that month. Everything else here is the same, and except we're going to call our new get customer birthday, pass inside of it the month of what would be September. And then what you have to do is put at and all of your different amounts that you have up here. So you would have birthday month. This is where it's going to be coming from. And again, at and birthday day, at first name, at last name, and at phone number. And close that off. And I think everything is right there. And if we come in and execute it, oops, I have an error down here. Let's go and correct that somewhere. I put BIR day. Oh, right here, get customer birthday. So everything else is fine, and run it again. And you'll see all the different customer birthdays that we have, which are right there. Another thing I don't know if I even showed you is if we go and refresh all, under the stored procedures, you're going to see all of those procedures that we have created so far all stored inside of the database, as well as the view that we had before. So pretty cool stuff. And now what I want to do is go and demonstrate if and else if and else. All right, so what we're going to do here is we are going to check for our monthly orders and to see if we are performing well or not. So I'm going to keep everything basically the same, except I'm going to change a couple different words here, a couple different names, of course. So I'm going to call this check month orders. And if it's at a certain number, it's going to say it's good. And if it's not, it's going to say it's bad. So let's go and do this and change this name of the procedure here. We're going to receive a month, which is an integer again. And then down inside of begin, we're going to declare a variable. And it is going to be total orders, which is an integer. And then we'll go select count and purchase order number. And then we're going to throw that into our total orders variable that we have. So that's where that's going to go. The value that is returned whenever we call count on purchase orders numbers. And then we'll say from sales order where, and we'll say month, time, order taken equal to the month that the user passed in. Now what we're going to do is we'll use if else and else if statements to check to basically provide output. So we'll say if total orders is greater than 5, then we want to output a message. So we'll say select concat total orders. And then we can say orders doing good. We'll say that if it's 5 orders or more, we're doing good. And then we can change our output for this to just output as the top of the table that's output. Then we can say else if total orders is less than 5, then, and again, we're going to use something very similar to this, so I might as well just copy it, paste that inside of there, and we can say doing bad. And then finally, as a default, if neither of those is true, well, we know we have exactly 5 orders, so we could say something like on target. And then after you're done with the if block, you have to say end if and put a semicolon. And now to test this, we can come in and let's just go check month orders and call get month orders. We don't need all this stuff, so let's just get rid of it. And then the month that we want to check, let's just check September again, and let's run it. And we see that we have 9 orders in this month of September, so we're doing good. All right, so there is another stored procedure, and of course it's going to be stored over here. And there it is. And now let's go and do another one where we're basically going to do everything we did here, except we're going to use case. All right, so basically everything is exactly the same, except we're going to use case in this situation. And basically case is going to execute different code depending on an exact value for total orders or a range of values. So we're going to say case and then follow that up with when total orders is less than 1, then, and if that's true, we will execute, well, I thought I had it saved, but I don't. So we'll say select concat and total orders. And again, we're going to print out exactly the same thing. So it's just another way of doing the same thing. We'll say terrible in this situation. And then we'll put that as output like we did before. And now let's go and copy this because we're going to be doing the same type of thing. Then we can say when total orders is, we can say greater than 1, less than 5. So you can stack them oddly like that. Shortcut. And in this situation, we can say get better. Again, do another when. And we'll say total orders equal to 5. Then, and do another one inside of here. And we'll say that this is on target. And then finally, as a default, we'll say else and paste in another one again. And in this situation, we'll say doing good as a default. And then after we have all those done, we have to come in and say end case. And you could also have these be, just individual numbers and so forth and so on, of course. And then check monthly orders. Let's just leave it at September again and run it. And you can see get better shows up. All right. So that's how we can use case and how closely it relates to the use of if, else, and else if. And just so you know, we would also be able to say case and put total orders inside of it like this. And then afterwards say when, one, then, and then execute certain code. All right. So more cool stuff, and now I'm going to show you how to sum up values to a maximum number using while. All right, so there's multiple different ways we can do loops here. So I'm going to show you the while loop first, and I'm going to call this loop test. And of course, change this to loop test. And this is going to receive a value. I'm just going to call it I. And then down inside of begin, I'm going to declare a couple variables. So I'm going to declare j, which is going to be an integer, and it's going to have a default starting value of 1. It's spelled declare right, of course. Then down inside of here, I'll declare another one, and this was going to be total sum, int, default value of 0. And then we'll say while j is less than or equal to I, continue looping. And here's how we set a value. So I'll go total sum is equal to total sum plus j. And then also we will increment the value of j plus 1. And then after this, we have to call end while loop. And then after we do that, we can output on the screen the total sum. So sum is equal to, and we'll follow that up with total sum. And we'll call this as sum. Of course, down here, this is called loop test. So we'll go loop test, call that procedure, and then throw a 5 inside of there as an example, and run it. And you can see that it gives you a final sum of 15. So there is one loop. And now I'm going to show you how to replace the while with the repeat loop. All right, so I'm going to keep everything exactly the same, except I'm going to say repeat and set total sum is equal to total sum plus j. And again, set j equal to j plus 1. And then what I'll do is say until j is greater than I. And then after we do that, we can say end repeat. And if we run that, you see we get the same exact result. So that's how repeat works in much the same way as while. And I covered a lot of things there, so why don't we now go and talk about cursors. Okay, so cursors are basically going to allow us to iterate through rows and work with them individually. So in this example, what I want to do is get a comma-separated list of companies using a cursor. So I'm just going to call this get companies. Get companies. And let's go and copy that and paste that inside of there. And I'm going to use in out, which is going to allow us to both receive a value and then output a value. So I'm going to call it company list, variable number of characters, and it's going to be 1000, and get rid of this integer because it's going to return a list in this. So that's the reason why I need so many values inside of there. First thing I'm going to do inside of begin is say declare finished, and this will be integer default 0, which is going to stand for false. And whenever this is set to the value of 1, we know that we've reached the end of the list, and we know that we can just output the information at that point. Also going to declare company name, and this is going to hold each company name from our list whenever we output them. So variable number of characters and 30 should be enough. And I'll have the default set to nothing. And now what I need to do is declare a cursor for our customer list, which is going to be populated by select. So to do that, you say declare, and I'm going to call this cursor company. And then you go cursor for, and then the select, which is going to be select company from the customer table. I'll then come in and handle whenever no more companies are going to be found. So declare continue handler. We'll get into error handling here soon. For not found set finished to 1. And that's whenever we'll know that we have all of our companies. Then we'll call open cursor company, which is going to initialize our result set. And then we're going to say get company colon and loop, which will continue looping until a leave message is called. And to get them, would say fetch cursor company into company name. And then we're also going to say if finished ever has a value of 1, well, in that situation, we will call leave, which is going to leave our loop. Leave get company. And then we can define end if. And then after we do all of that, we can go and add the company to our result. So set company list equal to call concat and company name, and then let's put a comma between all of them, and company, well, this will be company list. Close that off, and then we can end our loop, get company. And then after we have all of that set, we can release the memory assigned for our cursor. And to do that is close cursor company. And there we go. And then down here, we're going to generate our list of companies using our cursor. So first off, we're going to say set at company list and equal to nothing in the beginning, of course. Then we'll call get company, or companies is what I called it, right? Get companies. Yep, there it is. And go like this. And what we'll pass into it is our company list, which is going to be populated. And then after we have all that done, we can just say select and output our company list. And if we run it, you can see there is our generated company list. All right, so that's how we can use cursors. And now I want to talk about error handling. All right, so you're going to be able to handle errors in your procedures so that you can give understandable error messages, as well as maybe try to head off the error before it occurs using error handling. So what I'm going to do here is I'm going to actually on purpose create an error where the user tries to use a key already in use and then provide a custom error message. So I'm going to call this get product type. Actually, let's call it create product type, and go and copy that and paste this inside of here. This is going to receive a value, and that's going to be a product name. So product name, and that's going to be a variable number of characters, but we only need like 30 in this situation. And then we're also going to receive another one, and that's going to be product ID, which is going to be an integer. All right, so down inside of here, what we're going to do is to block what is called a duplicate key error. So we'll say declare exit handler for 1062, and that is the specific code for it. And then inside of it, we'll say begin, and we'll define a message that we can put on the screen. Say something like, you tried to use a key ID that already exists. You come over here, and here's a backslash with a quote if I didn't show you how to use those quotes in the output. You can't use ID, close that off, and then follow that up with the product ID that they passed inside of it, which is product ID. Close that off, and then we'll just say end, and let's tab that in so we can see where that's at. And then what we're going to do is try to catch any errors that are not caught by the above. This is like a default way to handle errors. So we'll say declare exit handler for SQL state. This is like the default. And again, you're going to do pretty much the same thing. You're going to say begin, and then you're going to output a message. So let's just copy this. And in this situation, because it's not a specific exception that was triggered, we're just going to say an unknown error occurred, and I'll put that on the screen. And then we'll say end again. And now we're going to actually create the error itself, or we're going to try to insert into our product type an ID that's going to trigger an error. So we'll go insert into product type, and we'll put name and ID and values, and that's going to be product name that was passed inside and product ID. And then I will have, let's say I want to output all of my product types if this does go through, but like I said, I'm going to make it go on purpose and mess up. If, however, up here where we have exit, if instead we typed in continue, this would execute no matter if there was an error or not. but we don't want it to do that. We want to just show our error message. And then down here, we can say call, create, product, type, and we'll say business casual, which is something that we don't have in our product type, but we're going to say we want to put it in the first ID, and that's going to cause the problem. And if we run it, you're going to see that we get our error message. You tried to use a key that already exists. You can't use ID 1. All right, so there it is. So that's how we would use a built-in exception that's inside of MySQL. And now I'm going to show you how to raise user-defined errors. Actually, I'm not going to change that many things in this. I'm going to keep it basically the same. So here, I'm going to say that I want to call this insert product type. And what I'm going to do here is block a user from entering a duplicate value in the product type table, because that would also be bad. So let's call this insert product type. And they're going to send in a product name as well as a product ID, just like they did before. And then I'm going to, inside of here, declare a new variable. So I'm going to go declare name in table int. And this is going to hold the result of checking for a name in product type. And you know what? This is all getting in the way, so let's just get rid of it. So there we go. Got a clean surface to work from. And we'll call this, we'll go insert product type. And then this is going to be athletic. So we will allow them, they're actually going to try to put this in ID 4, which would be legitimate since we only have 3 of them, but athletic's already in there and we want to block them from putting in duplicate data. So we'll go declare duplicate product name condition for SQL state. And I'm going to put 50,000 inside of there, which is just something that's not taken. And this is going to define the name for our custom error event. And then I'm going to say declare exit handler for duplicate product name. And this is going to, of course, be called if the custom error is thrown. Again, we'll say begin. And this is going to be the message that displays on the screen. And it's just going to be you. And I can just go and put regular old quote inside of there. I don't need to backslash it since I have double quotes around it. Enter a product name already in the table. And that's all I need to do. Put the error message inside of there. And now what I want to do is check if the name passed is already in the table. So I'm going to go set name in table equal to, and throw select inside of here, and I can do a count. That's a very easy way to figure out if we got a match or not. From product type where, and I'll put product type name is equal to, come over here, and product name, which is what was passed inside of it. Put that there, and that is, of course, this guy. See, product name. Then after I do that, I can go in here and use as an if statement. So I'll say if name in table, whoops, spell name correctly, name in table is equal to 1, well then, and I can signal for my error handling to, or signal that there has been an error. So signal duplicate product name, and else I will allow them to insert it. Insert into product type in the name and ID cells the values product name, which was passed in, and product ID, which was also passed in. And then I have to say, and if everything else here is fine, that's fine, that's fine, that's fine, as long as I don't have any errors. I ran it, and you can see, let's see, you have an error in your SQL syntax, check the manual, Oh, I accidentally typed condition wrong. It's always something silly. Condition, there we go, and run it. And now you can see that you can't enter a product name that's already in the table comes back. All right. Okay, so there's a way to handle custom errors that could pop up inside of your code. And now I want to talk about transactions. Now you're going to be able to combine multiple SQL statements using a transaction. And within the transaction, you can define when statements are committed as well as when they are rolled back. And of course, they would be rolled back in situations when something goes wrong. So what we're going to do is we're going to call this insert sales item. So let's go and copy that and let's paste it down inside of here. And this one is not going to receive anything. So let's just go and get rid of all those parameters. And then down inside of here, we'll declare SQL error, which will be either true or false depending upon if an error occurs. So I'm going to have this be a tiny int, and the default value is going to be false. Then we will say declare continue. This time I'm not going to exit. I'm going to continue. And we're going to look for an SQL exception. And if we get one, well, in that situation, we will say SQL error is going to be equal to true. And now we can start our transaction. And how you do that is go start transaction. And then we'll just list a whole bunch of them. So we'll say insert into sales item values. And we can throw 3, 263, 1. Actually, there's no point in me going and typing all those in. There they are. I put them all in there, and you can pause your screen if you want to type them in. Then, after I have those all in there, I'm going to say if SQL error is equal to false, then that means I want to commit all of these. So I'll just say commit. And then I can now put some information on it. So I'll say select, and I'll say sales items inserted, else, come out here. Well, then I know that I don't want to put them through. So in that situation, I'll say rollback, and none of those values will be inserted. And then I can put out a message that says that they were not inserted. And we can call this transaction rolled back. And then come in here and say end if, and change this to insert sales item. And then that's not going to receive anything. So let's just get rid of it. Everything's built in, and let's run it. And you can see that everything went through properly. All right, so cool stuff, and that's how transactions work. And now I want to talk about stored functions. Now, much as you created stored procedures, you're also going to be able to create your own functions, which are called stored functions. And your functions can only return a single value, however. It's very important to remember. And what we're going to do here is add up a order that you define. So let's come in. What are we going to call this guy? Let's call it get order total. So get order total. Get order total. And we'll change this from drop procedure to drop function. And we'll copy this, get order total, and we'll paste this inside of here. Of course, this is going to be changed also from procedure to function. And sales order ID will be passed in, and it's an integer. And what's important here is we have to define the data type that's going to be returned. This is going to return a decimal. So returns decimal, and we can put it on the second line if we'd like. We're then going to say deterministic reads SQL data. And deterministic means it returns the same result when the same exact argument is going to be passed inside of it. And we're also defining that we're going to be reading SQL data, but we are not going to be inserting it. Inside of begin, we'll say declare order total. And this is a decimal, 8 total digits with 2 decimal places. and order total. And then we're going to sum all the totals based off the sales order ID that's passed inside of it. Let's get rid of that. Don't know how that got in there. And we'll say select sum sales item quantity times item price as total. We'll put those into our order total that we defined right here. And then we just need to combine a whole bunch of different tables. So we'll say from sales order and do a join with sales item. So combine those two tables. And then we have to define how they're going to be combined, of course, using IDs, just like we have in the past. So sales order ID equal to sales order ID. And then we're also going to have to join this to the item table. So join item. And how we'll do that is on item ID being equal to sales item ID. And then we will also, well, that's all we need. So then we'll say where sales order ID is equal to the sales order ID that was passed inside. And then we can use a group by sales order ID. And then we can order by sales order ID as well. Then after we do all that, we can just say return order total. This ends, and then down inside of here we can go, well, that's basically all we need to do. So we can just hit our lightning bolt. We're going to actually call this from a different query as long as no error occurs. Doesn't look like it has. So let's go over here, do a refresh, and we can look over in functions and we can say get order total. There it is right there. Then we can come, let's close this, go file, new query tab, close that. There we are. And what we're going to be able to do now is do something like select sales order ID, get order total, pass in sales order ID, display it as order total, and then we're going to get this from our sales order table, and then order by sales order ID, as long as the function works right, and it looks like it did. And you can see right there, it's listing out all of the sales order IDs along with the total value. And in some situations, these orders don't have actual items in that, and that's the reason why you have null values. All right, so cool stuff. And now I want to talk about triggers. All right, so triggers are going to be executed automatically anytime a SQL query is executed on a specific table. So what I want to do here is create a procedure that checks if a customer with a new first and last name already exists. And if it does, I want to throw an error. So what I'm going to do here first is I'm going to go drop procedure if exists, and this guy is going to be called customer in DB, and create procedure, and customer in DB is going to be the name here. Throw that in there. And then of course we're going to be passed in a first name, which is a variable number of characters, which let's say 30 in length. And then we're going to also get passed in a last name. So let's throw that there, change this to last name, and that's good. And get rid of that extra comma there. We don't need a return statement here. And inside, we don't need deterministic either, or define that we're working with data, none of that stuff. All right, so inside of begin, we're going to say declare, and we'll say match found. Again, this is either going to be 0 or 1, depending upon if it was found or not. And then we'll say select count into, and we'll put match found. So if it comes back it wasn't a match, it's going to be 0, which is going to be false, and otherwise it'll give you another value and then it'll be true. And we're going to do this from our customer table, and we'll say where first name for our customer is equal to the first name passed in, and last name is equal to the last name that was passed in. Close that off. Then we'll say if match found, which means greater than 0, because it could be a value bigger than that. So we'll say if match found, whoops, put that there. In that situation, I want to signal that we had an error. I'll just have this be 50,000 again. And in that situation, we'll say set message text, which is going to be our error message, and we'll put customer already exists. Come down here, put end if. All of that is all perfectly fine. And now what I'm going to do is create a trigger. So let's just get this out of here, and I'll just go delimiter. Whoops, spell that right. Create trigger customers before insert, and we'll say before insert on, and we're going to tie this to our customer table, and we'll say for each row I want to do something, and I'll say begin call and check if it's in the DB, customer in DB, and it's going to be the new customer that we're trying to insert into the database. New again, last name, and then we can say end, reset the delimiter, and then we can come in and get ourselves a new query tab, and we'll go and try to find a customer, select everything from customer, and run this, and we see Christopher Jones. Let's look at these other different customers we have here. Jennifer Thomas. We'll have Jennifer Thomas be what we're trying to work with. So we got this here. Just put a lightning bolt, and then let's go and update this. Refresh all. Customer and triggers, and you can see customers before insert shows up inside of there, and that's the trigger we created, so that's where it is. And what were we going to do? We'll do Melissa Moore instead. Okay, so try to insert something that's already in there. So Melissa Moore is already there. All right, cool. And then come back here and do the lightning bolt again on this guy, and then let's come in here and let's execute it. And you can see that since it's already in there, it shows up that customer already exists. All right, so there you go, guys. That is a heck of a lot of information about using SQL with MySQL. Hopefully you guys enjoyed that. And like always, please leave your questions and comments below. Otherwise, till next time.